Hello everyone. Okay, today we are going to finish our DMVPN OSPF configuration journey. In last couple of videos we configured the DMVPN connectivity and backbone based on this diagram that you are seeing right now. And then we configured OSPF and ABR route summarization. As the last piece of the puzzle, now we are going to add IPsec Protection to our DMVPN overlay. So as you can see here in the objective, I have added DMVPN plus IPsec Protection. In the last videos it was just DMVPN. A couple of points before we jump into the configuration. So you need to know that DMVPN by default running on any transport kind of network like internet, MPLS, any kind of service provider network that is IP network backbone works just fine without protection. Okay. However, 90% of the situations in production, we also add a layer of protection, IPsec protection, to have security, integrity, authentication, and encryption for our spoke-to-spoke and hop-to-spoke communication over DMVPN. But you need to keep in mind that even without that, naked DMVPN works just fine. The only difference is that if you face a man-in-the-middle attack, someone just captures your traffic in between on transport network, and then they can see the exact traffic, what is going on between your devices. That's one point. The other point that I would like to highlight is that so when we talk about underlay and overlay technologies in DMVPN, so the underlay technology is the physical interfaces, the physical IP addresses, NBMA IP addresses of your transport network, and the overlay is the tunnel interface and the DMVPN technologies which are running over that. That's why it's called overlay. So that was a little bit confusing. I received some comments about that I wanted to clarify that. Okay. So before we jump into the configuration, I just want to check if everything is alright. I will just go to hub. As you can see here, show IP OSPF neighbor. It shows that my neighbors are up. 2222 is a spoke 2, 333 is a spoke 222 is a spoke 1, and 333 is a spoke 2. So if I do show DMVPN, I see that from hub point of view everything looks alright. So I jump into a spoke 1 here, and here show DMVPN. Okay, so here as you can see it's very interesting. On a spoke 1, which my NBMA address is 707070 based on the previous videos, and my tunnel interface is 192.168.0.7t, and the attribute is static. So it means that it's been a while that the spoke 1 hasn't talked to a spoke 2. So in order to simulate that, I just do a ping from to 10.10.20.1, the loopback interface behind the spoke 2, and I will source it from loopback 1, and it's successful. Now if I do again show DMVPN, you can see that here 5 seconds ago my NHRP resolved the overlay interface IP address, tunnel interface IP address of a spoke 2, and right now my NHRP is fine. So if I just do show IP NHRP, yes, we have a spoke to a spoke direct connectivity as well, so everything is alright. Now if I do here on spoke or hub or spoke 1 or spoke 2, do show run section crypto, I see nothing, and that shows that I have no IPsec configuration in place. Even if I do show crypto IPsec SA, no SA found. SA stands for Security Association. Okay, so let's kick it off. I will go to hub here. So I will start by configuring the ISACAM policy. In this video, I assume that you already know the basics and principles and concepts of IPsec technologies, IQ version 1, IQ version 2, and how we configure authentication, encryption, and this kind of stuff. So I'm not going to explain the basic and foundations of these concepts to you guys. I assume that you already know, so we just jump right into the configuration. So we put crypto ISACAM policy. You can put any number. I will put it 20. Here, authentication pre-shared key, encryption, I would put it 3 des, but of course in production you should put it much better. You should assign a better stronger element encryption method. Diffie-Hellman group I will put as 5, and what else, hash MD5. Again, in production it's more recommended to have SHA-2 512 or 256, so it's just for the sake of this lab scenario. Okay, authentication, encryption, group, hash. Now we have defined our secure ISACAM policy. Then I would do crypto ISACAM key. Oops. Crypto ISACAM key, whatever you can put, Cisco 123. Here I would put address. Now I just put 000. It means that you can accept this key from any peer with any IP address, right? Okay, now we will define our transform set, crypto IPsec transform set. I put it as a strong set, right? And ESP 3des, for example, as an encryption method, and ESP MD5 HMAC, right? Here I just don't want to change anything. The mode is already I would leave it as default, so exit. Now I would define my IPsec profile, crypto IPsec profile. I will assign a name, my profile, right? Here I would set my transform set, which was, I think, a strong dash set, right? And I can set also here, I can add description or other options like responder only. That if I put responder only, it means that this hub is not going to initiate any SA negotiation, but I'm not gonna change anything. Or you can also assign a PFS, but I will leave it as default. So the profile is ready right now. So far we have defined the IPsec ISACAM policy, then our transform set, then our profile. Right now we just have to tie the profile to our tunnel interface. So I do show IP interface brief and tunnel 0, show run interface tunnel 0, do show. So I will add the configuration to this that line of the protection to this configuration. So interface tunnel 0, tunnel protection, IPsec profile, and what was my profile name? Yeah, my profile. That's it. And bingo. So as you can see, the first message I saw on the terminal is crypto ISOCAM on, and the first thing we would see is that there are a couple of errors, that, hey, the protocol I'm receiving is 47, which is the GRE default protocol, and the packets are not really encrypted. So we should expect that after the we reach the dead interval timer of our OSPF neighbors, they should go down, because we are not talking with the same protocol anymore. As you can see, I lost my neighbor, OSPF neighbor relationship with 3333, and here we go 222. So right now we have broken the DMVPN backbone, and that's pretty normal. So I will do show run section crypto, and this is all the configuration that I would need for others as well. So I will just copy it right to text editor. I will just add a new one here, close this one. Okay, so I would exactly copy the first one. I mean, for other spoke 1 and spoke 2, let's just review. Yes, it has to be match, encryption, hash, authentication, and Diffie-Hellman group for key exchange, and then crypto ISOCAM key. So I think it's already, we are good to go. So I will just copy this, and we jump into spoke 1 conf, and we copy everything. Yes. Okay, right now everything is alright from the cryptography, from the crypto configuration, but you shouldn't forget that we should add that the whole IPsec profile to our tunnel interface. So show IP interface brief conf interface tunnel 1 tunnel protection. Wait a second. Tunnel protection IPsec profile, my profile. Okay, ISOCAM is on, and immediately our neighbor relationship is restored with the hub. Okay, which is neighbor 111, which is router ID, OSPF router ID of our hub router. Okay, so we are good to go on a spoke 1. I would put on a spoke 2 as well, the same configuration here. Just a second, I just tidy up my desk. Here, spoke 2. As you can see here, we lost our neighborhood relationship OSPF one. So now conf, and again paste everything. Looks alright. Interface tunnel 2, tunnel protection, IPsec, my IPsec profile, and my profile. Bang. So immediately our ISOCAM came up and our neighborhood came up again. So we have restored our DMVPN connectivity plus our OSPF connectivity, plus we have added a new layer of protection, IPsec protection, to our DMVPN. Let's check everything. Show DMVPN. Let's check if I can ping the network behind my hub, 172.16.0.1. Yes, I can do that. If I can ping, just lost the window. If I can ping also the network behind my spoke 1 as well, which is 10.10 10.10.1. I will source it from my loopback, so LAN to LAN, and here we go. Okay, so the DMVPN works, and how we can make sure that our encryption and IPsec works. Okay, in GNS3 you can do packet capture, Wireshark, and you can see that it works, but I wouldn't do that because I have a enterprise level of Bitdefender antivirus that I don't control on this laptop, and it it has some conflicts with Wireshark, so I cannot properly launch Wireshark on this GNS3 platform. So the other way, or let's say more professional way to check if your IPsec protection works, is just check your crypto IPsec SA. And here, as you can see, I have my SA to be defined precisely here. If I go up here, as you can see, the local identification is 1999, which is my NBMA address, and this is the NBMA address of a spoke 2. As you can see, packet encapsulated 5, packet encrypted 5, and packet digest for integrity is 5. This is the ping that I sent to a spoke 2, the network behind that. And if I come down, this is my IPsec communication with the hub, and I have more packet encryption as well. Statistics I have more statistics for packet encryption and decryption and digest as well. And the reason is that I was talking to my hub when I did my configuration. There were some communication going on for NHRP and so on. So just to make sure, again, I would do ping again 10.10.10.1, which is the loopback address behind my network my spoke 1, right? Loopback 1, LAN to LAN again, but this time I will repeat it 10 times. It's successful, so if I do show crypto IPsec SA, I should see 15, and that's correct. It shows that all configuration are right, and we have added IPsec protection to our DMVPN, and we are running smoothly DMVPN up to phase 2 plus OSPF on our hub and spokes. We have OSPF, we have a spoke to spoke connectivity directly via OSPF, LAN to LAN, and also IPsec. Thank you for watching. I hope it was informative for you.